Imagine watching a cyclist. We are not asking whether the cyclist moved at exactly the same speed at every moment. The cyclist might slow down for a bend, accelerate downhill, or wait at a traffic light. For now, we ask a simpler question: what total distance did the cyclist travel, and how much total time did it take? Suppose the cyclist travels 300 meters in 60 seconds. During those 60 seconds, the cyclist accumulates 300 meters of motion along the route. If we spread that motion evenly across the full time, how many meters correspond to 1 second? 300 meters divided by 60 seconds equals 5 meters per second. This does not claim that the cyclist actually traveled exactly 5 meters during every individual second. It says that the total distance, when distributed evenly across the total time, is 5 meters per second. That is the idea of average speed based on distance traveled. Average speed tells us how much distance an object covers, on average, per unit of time. The word average means that one number describes the entire observed motion. It does not have to describe each second separately. If the total distance traveled during an interval is delta s, and the interval lasts delta t, then the average speed, written v-bar, is delta s divided by delta t. Delta s is the distance accumulated along the route during the observed motion. Delta t is the total elapsed time. The bar above v tells us that this is an average value. The formula simply records one idea: average speed equals total distance traveled divided by total elapsed time. This gives us two useful comparisons. If two objects move for the same time, the one that travels farther has the greater average speed. If two objects travel the same distance, the one that takes less time has the greater average speed. For example, car travels 100 kilometers in 2 hours. Its average speed is 100 kilometers divided by 2 hours, which equals 50 kilometers per hour. Car B travels the same 100 kilometers in 1 hour. Its average speed is 100 kilometers divided by 1 hour, which equals 100 kilometers per hour. Car B has the greater average speed because it covers the same distance in less time. Now reverse the comparison. Both cars travel for 2 hours. Car A travels 100 kilometers, so its average speed is 50 kilometers per hour. Car B travels 160 kilometers, so its average speed is 80 kilometers per hour. Car B is faster because it covers more distance in the same time. Average speed based on distance is a scalar quantity. We give its magnitude and its unit, such as 5 meters per second or 80 kilometers per hour. We do not need to add right or left, because average speed is calculated from distance, and distance is scalar. It adds the total length traveled along the route. For the same reason, average speed cannot be negative. Suppose a car drives 10 kilometers away and then 10 kilometers back. Its total distance is 20 kilometers. If the complete trip takes 1 hour, its average speed is 20 kilometers divided by 1 hour, or 20 kilometers per hour. The car returns to its starting point, so its displacement is 0. But it really traveled 20 kilometers. Average speed remembers the length of the route, not only where the car finished. Physically, average speed tells us how quickly distance accumulates over time. An odometer records the distance. A clock records the elapsed time. Dividing the odometer increase by the elapsed time gives the average distance covered in each unit of time. So when solving an average speed problem, identify the complete observed interval at every part of the route, include the full elapsed time, and divide total distance by total time. If this explanation helped, please like the video, subscribe to the channel, and leave your physics question in the comments. We will do our best to answer it.